Students, I welcome you all for today's practical session, experiment number 24. The aim of the experiment is connect and test IR proximity sensor to a digital circuit. So here we are constructing one circuit. Here we are constructing one circuit, that is IR proximity sensor circuit, to a digital circuit. Here I am using one LED. If I send one to that LED will glow, otherwise LED will be in a off condition. Okay, so this one I am using. For this, this is the circuit diagram for a IR proximity sensor. In circuit, here we are using IR LED. This is called as IR LED. So the IR LED emits the IR light, which is also called as transmitter. Next we are using IR diode. This is called as a detector or receiver. So when IR diode emits the light, that is IR light, this photodiode or IR detector it detects the light, and according to the intensity of the light it produces the voltage. So these two are very important. In pair we have to use. And for IR diode, 220 ohm resistor is connected, and for IR photodiode 10 kilo ohm resistor is connected, and one 10 kilo ohm pot is used in order to vary the voltage obtained from the IR photodiode, and one LM358 op amp is used. This is an IC where we have an op amp. This op amp can be used as a comparator in this LM358. This is 8-pin IC. Among 8 we are using 5 pins only. Pin number 8 is VCC. Pin number 4 is ground. Pin number 2 is inverting input terminal. This is called as inverting input terminal of op amp. And pin number 3 is non-inverting input terminal of op amp. And pin number 1 is output. This is output pin. So this LM358 IC we are using. Then one normal LED we are using. So this is the output LED. Whenever it produces the voltage, LED will glow, and we require 1 kilo ohm resistor to connect to this LED. And we need one battery, 5 to 9 volts battery. You can use power supply, or if you have a 9 volts battery, you can use 9 volts battery. So this is positive rail, positive supply, and the bottom one is negative rail, or we can call it as a ground. And one output I am taking from the anode. So here I am taking the output, right? So this is the circuit diagram of IR proximity sensor. Let us construct this circuit on the breadboard. See students, this is an LM358 IC. This is an LM358 IC. Here there is a small notch here. The notch indicates pin number 1. Next pin number 2, 3, 4. And exactly opposite to 4, pin number 5, 6, 7, 8. The last pin on this side is 8. The first pin in this side is pin number 1, and this is pin number 4. So according to the circuit, pin number 4 should be connected to ground, and pin number 8 should be connected to VCC. Now I will do the connection. I will take a small wire. I will connect pin number 4 to ground. See students, I connected pin number 4 to ground. Now I have to connect pin number 8 to VCC. Pin number 8 to VCC. Okay. Then according to the circuit diagram, see the circuit diagram once again. So we need one 10 kilo ohm pot between VCC and ground. Okay. Now I'll use 10 kilo ohm pot. This is 10 kilo ohm pot. So the 10 kilo ohm pot, the extreme end of one 10 kilo ohm pot and the other extreme end I'll connect it to VCC and ground. Okay, let us do the connection now. one extreme end of pot I am connecting to ground and one extreme end of pot I am connecting to VCC. I connected. Then see the circuit diagram. The pot middle point, it should be connected to pin number 2 of LM35080. This is inverting terminal. Okay. So in this pot, this is the middle one. You should connect it to pin number 2 of LM358. See, I connected to LM358 pin number 2. Okay. Next, we should use one photodiode. This is our photodiode, which is black in color, and it has two leads, one bigger one and smaller one. Bigger one represents anode, smaller one represents cathode. See the circuit here. The cathode should be connected to positive supply and anode should be connected to 10 kilo ohm. Okay. Now I'll connect photodiode like this on the breadboard. So cathode should be connected to where? Cathode should be connected to positive supply. It should be connected to positive supply. And where the anode should be connected? Anode should be connected to 10 kilo ohm resistor. This is 10 kilo ohm resistor. 10 kilo ohm resistor should be connected to ground. Okay, I connected this to the ground now. Okay, then see the circuit once again. IR LED, anode of IR LED should be connected to VCC. Cathode should be connected to 220 ohm. 220 ohm should be connected to ground. So this is my IR LED. See students here. Again it has one positive lead and one negative lead. Longer one is anode, smaller one is cathode. Anode should be connected to positive supply. You insert properly the connection. Then take the anode connection. Connect it to positive supply. Okay. And negative should be connected to 220 ohm resistor. 220 ohm resistor should be connected to where? It should be connected to ground. Okay. So I connected this to the ground. Next, see the circuit once again. This part is over. This part is over. This part is over. VCC is over. Ground is over. Now I should connect pin number 3 to anode of photodiode. Pin number 3 you connect it to anode of photodiode. So here this is your pin number 3. Connect this to anode of, this is our photodiode. Connect this to the anode of photodiode. Okay students. So I connected this to the anode of photodiode. See, I'll use the smaller one. Pin number 3 to anode of photodiode. Okay students. So I connected this to the anode of photodiode. Next, pin number 1 should be connected to LED. This is my normal LED. See here circuit. Pin number 1 should be connected to normal LED. Cathode should be connected to 1 kilo ohm. 1 kilo ohm should be connected to ground. Okay. Now I'll use this LED and the anode should go to pin number 1. This is my pin number 1. And from cathode of the diode, it should be connected to ground. Okay, I connected this to the ground. Okay, now the last circuit you see in the diagram, battery of positive should be connected to positive rail and battery of negative should be connected to negative rail. Okay, so I am using this battery, 9 volts battery, and this is a battery cap. Connect this to the battery cap. This is positive supply, this is negative supply. Positive I am connecting to positive rail here. And the negative should be connected to negative rail. See students, now it is glowing. The LED is glowing because it is producing active low output. Now, whenever I bring an obstacle, now students, the light LED is glowing. Now these two, when I bring the obstacle near the IR LED, now how the light will turn off, I'll show you. I am bringing the obstacle near the, now the obstacle when I bring near to the LED is becoming off. If I move the obstacle away, LED is glowing. When I bring the obstacle near, LED is off. When I move it away, move the obstacle away from the IR LED is glowing. Again I move, LED is off. You can see here. So you can, when the obstacle is coming near the IR LED, the LED output LED is not showing glowing. When I move the obstacle away from the IR LED will glow. So this indicates that the circuit is working as a IR sensor which is sensing the obstacle. Okay students, I hope everyone understood this experiment. Thank you. Hello students, now just now you saw the circuit diagram and you constructed the IR sensor module using the individual components, discrete components you used. So that is using this circuit you can do the mini project in your college or institution. Now I show you to construct another IR sensor circuit using the ready-made sensor module which is available in market. You can bring the sensor module and you can do the connection. It is very easy. I'll show you what is that model and how to do the connection and how it detects the obstacle. Let us go to the lab and do the experiment now. This is an IR sensor module. This is an IR sensor module. See here, IR photodiode and IR LED. Both are in pair. And this is a pot, 10 kilo ohm pot. And these three are jumper wires which are connected to the 3 pins, output pins of this IR sensor module. So you can get it in the market, these jumper wires, and this IR sensor module just cost around 75 rupees students. You can bring it. Okay, I am using this, and to connect it to a digital circuit, I am using one normal LED and 1 kilo ohm resistor I am using. So you can use 220 ohm resistor also in this if you don't have a 1 kilo ohm resistor. Okay, let us do the connection now. This is the circuit using the sensor module. Okay, so this sensor model, what I have shown here, there are 2 diodes. So I have used the diodes symbol here. One is IR photodiode and one is IR LED, and 3 pins for the output, VCC, ground, and the output I am taking. And the VCC should be connected to 9 volts battery, and ground should be connected to negative terminal of the battery, and output should be connected to an LED and to the 1 kilo ohm resistor. So now we'll construct this circuit on the breadboard. I am using a 9 volts battery. So first you connect the battery cap to the battery. Yeah, I connected. and this I'll connect it to positive rail, and this you connect it to the negative rail. So this is positive supply, this is negative supply. Now you have the pin, this is VCC pin. So connect one small connecting wire to this jumper wire or connecting wire and connect this to the VCC. And the second one is ground. Connect one more wire, small wire, single strand wire. Connect this to ground. Connecting this to the ground. Okay. Next, the last one is output pin. The output pin you connect to the LED. So I am connecting LED here. This pin, the positive supply, the positive of the diode should be connected to this. And to the cathode you connect one resistor, and which you connect to the negative supply, that is negative terminal of the battery. Okay, so now connection is over. Okay, so now we'll connect this to okay, now the LED is glowing here. So why? Because obstacle is far away now. Now I'll bring the obstacle near. See, LED is becoming off. I'll bring the obstacle far. The LED is glowing. I bring it, LED is off. Move it on. Bring near, off. So this module is also detecting the obstacle. Okay, so this distance what I am moving here, the distance can be varied with the help of a pot given here. There is one small pot given here. So if you can see the pot here, blue color pot. So if I vary this, the distance can be adjusted. Okay, now I will vary the distance. Okay, so I varied the distance. So now see, earlier I was about 2-3 centimeter. Now up to 4 centimeter it is showing. See, 4, 5, 6, 7 centimeter also it is showing. So you can vary the range with the help of this pot. Okay, so this is very easy, students. You can buy this and do the experiment. Thank you.
Now, I would like to thank Srimati Shanta C. Mukartihal Madam for conducting the experiment on how to connect an IR sensor module to a digital circuit. Thank you, Madam. The LMS e-content team members of the course Fundamentals of Electrical and Electronics Engineering are Srimati Sudharani DJ, myself, e-content developer, Government Polytechnic Chintamani, Srimati Shanta C. Mukartihal, course exporter, Government Polytechnic for Women, Bengaluru, and Shri Wazid Ahmad Sir, the course moderator, Government Polytechnic Immadihalli, Bengaluru. Thank you.